Hello, my name is Paolo, this over here is Milo. Today we're going to do the second part of the Among Us wires tutorial. Previously we got one of the wires connecting, so now we got to create the other wires, randomize them around, give them their own colors, and then making it actually work to detect when you win and then restart it over. Okay, so first let's test where we left off. At this point we have this wire over here. If we let go over here, it just stays there. And then if we get close, it auto connects in there. So the first thing we want to do is make it so that it resets if we don't connect it. So for that, let's open our wire script. So here we would go to the event on mouse up, which is when we let go of the cursor. And we would like to reset the position back to the original position. The problem is we don't know that original position. So let's save it first. So for that, we can actually go here and we just can say vector 3 and call it original position, and in the start function, which will run the first frame that this is created, we can actually set it there. So original position is gonna equal, and then in here we can basically grab the position of our wire. If you remember, over here on set position is where we're setting it by doing transfer position equals p position. So basically this one is the original one. So we can just basically put that here. So when the game first starts, it will save the position it's at that particular moment, and it will just save it for posterity. So then we can use it later to move the wire back. So in here we can just call set position, and in here we can call original position. So basically this will return it to where it started. Now when we test it, if we let go, as you can see, it resets. Now it does have a little bit of a problem, which is when we connect here, then I let go of the cursor, it goes back. So that's no good. We need to tell it, hey, only do this if you're not connected already. So at this point we have no way of knowing if it is connected or not. So over here we can add another bool, and we can say bool connected equals false. And then in here where we're doing the connection, we can say over here connected equals true. And finally in our mouse up, we can just do a check and say if it's not connected, which we can do with that exclamation sign. So we say if it's not connected, then put the position back to where it was. So this still works, and then now when we connect and we let go of the cursor, it stays connected because we have that check. Now we're gonna do something right now that we don't really need to do yet, but we're gonna need it later, which is basically this call here essentially resets the wire back to where it started. Later on in the tutorial, we're gonna do something to restart the whole game, and we're gonna need to reset the position of every one of the cables. So for that, let's change this into a function. Just like we did before, we can declare, over here we can declare a function, we call it void reset position. Then we can put this here. And then in here, what we do, just like we did before, we just call reset position. And it will work exactly the same, only later on when we need to actually reset the position of the wires, we can actually call this. Excellent, so now that we have that, we need to get our other 3 wires. Right now we only have one, so we have wires 1 over here. So you can come over here to our hierarchy and just do Control D, or you can just right click, duplicate, either one works, and that will make new copies of this. So we can just rename this into wires 2 and into wires 3, and then let's make one more copy, which again I did with Control D, and let's just rename that to wires 4. And then we can grab each one, and just like before, we can use this little widget here to move it down. So let's put wires 2 like around here. Wires 2, 3, let's move it here. And finally wires 4, let's move it all the way down here. And obviously the colors of the wires are going to be wrong at the moment. So what we can do is we can just go to, for example, wires 2, which is right here. And we can grab the line here and the line inside of here. You can just select both by clicking on one and then holding Control and then clicking on the other one. So So now you can see on the right, on the properties, we can see the color. We have the red right now. Let's click on that. Just like before, this is a gradient. So we gotta select one color. Let's change that to the blue. And then this one here, same deal. Let's click on that. Let's click on the blue. And now we have our second line now is blue, which is great. And we can do the same for our third line. So again, we expand this, click this one, control, click this one. Then we get the red. We can change that maybe to a yellow one. And we do that for each one of the lines. Perfect. Now we have 4 lines, each one of different color, and let's just test that they do connect. So I can grab the blue. If I get close to a red, no connection. But if I get close to a blue, it connects right there. And then it connects here, connects here, connects here. Perfect. So we can connect all 4. We're not able to reset this yet. And obviously it's not a very interesting minigame if they all connect directly. So the next thing we need to do is add a way for it to actually scramble where these positions happen. Let's collapse these ones, and for that we're going to add a new object here, and we're going to create an empty object, and we're just going to call it game logic. And then to it we're going to add a component, and we're going to call it game logic as well. And as you can see, Unity offers you here the option for new script. So when you click on this, it actually will name it whatever you were searching for. So we can create and add it. And once Unity is ready, you can double click game logic. Okay, so we have a brand new script for our game logic. So let's start with getting access to all our wires. And for that, we're gonna do public, and then we're gonna create what's called a list. And a list, basically, as the name implies, will hold a list of objects. So basically we can use that to kind of hold on references to our 4 wires in this case. So this is going to be a list of wires. You basically tell it which type do you want within this little brackets, and that's what tells it what this is. And just for a name, let's call it wires. Since this is public, we will actually get to see this in Unity. I'm back in Unity. As you can see now, we have this list that is empty called wires. So this is expecting the type wire. So you remember earlier when we made this parent, this doesn't have a component of wire. The component of wire is actually inside of here, and it's under this. This is the wire component, and this is what our game logic is expecting. So you can grab these exposed wires and just drag them on top of this, and it will add it here. And let's do that for the other ones. There you go. We now have our 4 wires. And now just to show you, you can actually remove all this. Now that we deleted it, we can do it in a different way. So over here you can see there's this little lock. You can use that so basically this inspector stays looking at game logic. And no matter what you click on, you can see this stays as game logic until I remove this lock. So now I can go in here and just click on exposed wires, then hold Control, click, click, and click, and I've selected all 4, and I can just drag them directly here, and it fills out the list. Now, after I'm done with this, I do need to remove this lock so that I can look at the properties of other objects. It's just a different way to achieve the same thing, just showing you a few of the options that Unity has. So what do we want to do with our wires? Well, we want to move around the little end caps around so that they basically appear random every time. So, you know, this one appears here, this one here, this one here. So they're shuffled, and every time you play the minigame, it's a little different. So how do we do that? Well, under wires, we made this end wires object. So all we need to do is move this one. Now, if you remember from the previous tutorial, we actually were nice enough to add this end wire variable here, which is already pointing to it. So we already have access from code to it. So that makes things quite a bit easier. So how this will work is basically it'll grab a random index from 0 to 3, and then that element will get moved to the beginning of the shuffle list, and then it will do a second element, a third element, and so on and so forth. So for example, in this case, it grabbed the third index and moved it to the beginning, and then it removed it from the original list, so that when we go to grab a new index, we don't grab the same one again. And then over here, we grab 1, we grab 2, and we grab 0. If we try that again, now we get 3, 2, 1, 0. So actually the list ended up basically being flipped. And one more time, 0, 3, 1, 2. So as you can see, every time we'll get some different result. So here we're going to create a function. We're going to call it void shuffle wires. And this will take care of moving all our wires around. And the first thing we're going to do in here is make another list, just like before, but this time instead of holding wires, it's going to hold on to vector trees. And this is going to be for the end wire positions. So end wire positions. And then that was going to equal a new list of vector tree. So basically here we're saying we want a list of vector trees, which if you remember is what we've been using for the position of all our objects. And over here we're just basically creating it just so that it actually exists and we can use it. Now down here we actually want to go through each one of our wires and put the position of that wire into our list of positions. So to get the position of one of our wires, we can say vector tree position, and then this will be equal to wires, and then we open the square brackets in here, and in here we'll take a number from 0. It can be 0, it can be 1, it can be 2. Since our list has 4 objects and the list starts counting from 0, that means it'll be on 0, 1, 2, and 3. Those are 4 objects that we have. Why it starts in 0, there's some conveniences in code, and it's just a pretty established norm that lists count the very first object in the index 0. So it's just something you gotta get used to a little bit, but once you get used to it, it's pretty easy. So in here we could say wire 0, which would be our red wire, the one that's at the very top, and then just do dot, and we already added access to the end wire, and that's called end wire, and then we can do dot, and then just position. Pretty easy. So that's how we get the position of the wire. Now it would be kind of uncomfortable to copy this and have to put like 1, 2, and 3 for each one of these, and then over here have to put position 1, well, position 2, 3, and 4. Like it would be pretty awkward to have to do this. So instead of that, what we use is something called a for loop. So a for loop is used basically to repeat the same action a certain number of times. So in this case, let's delete this part. And we're going to create a little for loop here that's going to say for each, and for each wire W, let's just call it W, but this basically is any wire in wires, do something. So basically this will say for each one of the wires that we have in this list, put it in this variable W and do something to it. So now we can actually move this line that we made earlier to grab the position, and instead of having to say wire 0, we can just change this into W. Now what do we want to do with that position? Well, we created this list here that is going to keep tabs of all our positions, so we can just say end wire positions dot add, and this will just add an element to it, add an element to our list. And over here we just say pos, and that's it. We first add each one of the positions into the list, and now we want to take them out in a random order. So we want to actually do another loop on wires, so we can just grab this for loop, and then in here now we want to do something different inside, but it's basically the same idea. So now that we have the positions, we know there's 4 positions in here, 1 for each wire. So what we want to do is grab one at random and then put that into our list. So here we're going to say int random index, and this is going to be equal to, and Unity has a pretty nice library for this. It's called random, as you can imagine, dot, and then you can say range. And the range would basically give you the result between 2 numbers. So we want to start at 0, because like we said before, our array starts at the index 0, and we want to go up to the maximum it has. Now we know right now, for example, wires, there's 4 of them, so we know the maximum we want to go to is 4. If you look at here on the tooltip for random range, it says the minimum is inclusive. That means you can actually get 0, but the maximum is exclusive. What that means is basically that if you put the number 5 here, you will never get the random number 5 out of it. It will only go up to 4 because the maximum is exclusive. So what is the maximum number we want to get? Well, this index is going to be used to read a position from this list of end wire positions. So we can do end wire positions dot count. And that actually tells us how many wire positions there are. So since we just did this step, we know that there's 4 end wire positions here. So basically it'll do a random range from 0 to 4. And now we want to use that random index. And for that, we're basically going to do w.endwire.position. It's going to equal to, so over here we were reading from end wire position. Now we're going to write to end wire position. So we go here, end wire positions. And like I showed you, we can use the square brackets to index a particular value in there. So let's use random index. Okay, so this will actually shuffle them around. Now we just have to call the function. It still has one big problem, but I think it's easier if I show you the problem rather than just tell you about it. So when we run the game, we can see the blue is here, that's great. The red is here, that's great. The yellow is here, but where did pink go? It's a mystery. Well, it's not that much of a mystery. Let me show you. We go back to our scene and we select our pink wire. We can see here on our end wires, aha, they're behind that. So the reason is that these two ended up in the same index. And that happens because we're grabbing the indexes at random, but if random number lands in the same number twice, then we get the same position and then our cables overlap. So we need to make sure that no two wires grab the same position. So for that, what we do is basically from end wire positions dot remove at, and we're just gonna remove the position that we just used. So that way we know it's not gonna be used again. And now when we run, you can see they're shuffled around and none of them are overlapping. So now I can grab the red. If I try to connect it to the pink, it doesn't work. But if I go to red, it does work. Blue with blue, yellow with yellow, and pink with pink. There we go. So next thing we're gonna do is actually check if all of our wires are connected. And for that, we're gonna need to be able to ask the wire, hey, are you connected? So in wire, we have this connected Boolean, and this is what tells us if we're connected or not. And that's what we want to read from game logic, but we're not able to because it doesn't have this public tag. Now, we could easily just add the public tag here and just paste it in here, and that's it. And that is a very easy way to solve this. I'm going to show you a different way just to kind of show you a little more of what you can do with code, and something that's a little more like an appropriate way of doing this. So down here, we can create a couple functions, and we can create a public. And then we can, so far we've been saying void for all of them, you know? We've been saying void, void, void. What does void mean? Void means nothing. Essentially, void is we're gonna return nothing. And instead of that, in this one, we're gonna say bool. And as we've said before, Boolean is basically a true or false flag. It says, is this true or is this false? That's it. And in here, we're gonna ask, is connected. That is what the function is going to have. And in here, we're just going to say return connected. And basically, the value that you're returning here needs to be of the type that's set here. So this is saying this is going to return a bool, and over here, we're returning a bool. Now, why do you want to do this instead of just doing what I said earlier, which was you could just write public here and you'd be good? Well, there's a couple of reasons. If we save this and go back to our editor, now you can see connected appears over here and you can turn it on and off. Now, there's no reason for you to turn this on and off before the game even starts. So this actually is just adding like more noise to your interface that is not really necessary. The other reason is to keep your code a little more safe. So for example, let's make the function that changes this variable, not only reads it. So down here is connected is actually reading the variable. Let's make another one that's called public. We're going back to void because we don't need to return anything here. I'm gonna call set connected. And in here, this is going to take a bool, and let's call this p connected. And at the very basic thing it's going to do is basically going to say connected equals p connected, and that's basically just going to take whatever variable you passed in here and it's going to save it here. So at this point it doesn't look very different than what we were doing up there, but one thing that we could possibly add it to set connected, we could say if not connected, then we can say reset position, because we're calling it for it to disconnect, right? So we want to disconnect it here, so we also want to move the position. So now we have this extra functionality here that's very convenient. If we leave this public, then people could just call connected equals false and forget that they also need to reset the wire to be disconnected. Hope that makes sense. It's a slightly more intermediate thing that you don't totally need to do, but it's good practice. So back in game logic, now we can actually check if each wire is connected. So for that, we're going to do over here, we're going to declare an int, which is just a number, and that is going to say connected wires. And since we haven't checked anything right now, we're going to start at 0, and then we're going to copy our loop that we've been doing here. This loop has, as you can see, been very, very useful. And we're going to say if w dot is connected, which is the one we just checked, then we can do connected wires plus plus. And connected wire plus plus is the equivalent of doing connected wires plus equals 1. It's just a different way of writing the same thing. It's just very, very common to do this plus plus just when you're doing just one. And just to make sure that this is working, down here we can check if connected wires equals wires dot count. That means all of them are connected. And for now, we can just basically disconnect them once they're done. So basically the game sort of resets. So once again, we're going to use our trusty little for loop here. And in here, we're going to say w dot set connected false. And that should disconnect them all. So we connect red here, yellow, blue, pink. And as soon as they were all done, it reset them back in. And this works just fine. And we can just basically do it again. So we're good to go. So over here, let's create one more function. Let's make this public void. Let's call it reset wires. And that's basically going to do the same thing we just did. We're just going to move where the code is. So we're going to grab it from here, copy it, then paste it here. And then we're going to call reset wires. Now, we not only want to reset them, we also want them to get shuffled again, because we don't want the combination to be the same every time. So with this, we can actually reshuffle all the chords. So we have yellow, pink, red, blue. And now we have blue, red, pink, and yellow. So every time we complete it, it'll reshuffle again so that we get like a different combination every time. Now let's make that transition a little better by adding the well done message. So we can just basically click and drag it in here, or click and drag it in here, and that will basically make it appear here. So after we drop it, if you look closely, the lines are actually drawing on top of it, which obviously is not what we want. So just like we did for the background at the very beginning of the previous tutorial, we can add a new layer for it. So over here, we can do add sorting layer, add a new one, and let's call this message. And then we can select it again and then change this one to be message. And as you can see, now it's above the lines. So it doesn't do anything right now. So let's add a component to it. Once again, we're going to do a new script, and let's call this end message. So the first thing we're going to do is that right now when we run this, it will actually be on top of everything. So we want to make it so it hides itself when we first start the game. So over here on the start, we can do game object dot set active to false, and that will basically make it hide itself. So now when we run, you can see it's gone. The next thing we want to do is from the game logic, we want to have access to it. So over here where we did our list of wires, we can also do public game object. And then let's call this one end message. And now in here, instead of doing reset wires, we can actually replace this and just call end message dot set active to true. And that will turn on the message once again. So we select our game logic, and over here we can see we have end message. It's empty, so we can just grab end message and just drag and drop it in there. And now we do red, yellow, blue, and pink. There we go. Now we got the well done message. Now it doesn't do anything right now, so we gotta give it some functionality. And just like we had to do with the other ones, in order to be able to click it, we have to add a box collider to it. So let's add this. And since we also want to block any clicks behind it, we can actually make this a little bigger. So over here you can see we have a size property, so we can actually kind of cover the whole screen just so that you cannot click anything behind it. And in the code, if we go back to end message, we can actually go and what do we need to do? Well, when we click, we want to call a function in game logic to reset the wires. So we go over here. We need access to the game logic first of all. So we can do public game logic, and let's call this just game. And then we can create a new function here. We don't actually need the update, so we can delete this one. And then in here we can create void on mouse up. So when you let go of the mouse on top of this one, we can call game dot reset the wires. And also the same thing we did here, we want to hide the message once it's done. And we select that message, you can see we have game here, and again this is empty, so we gotta grab game logic, drop it in here. And now when I drop red, pink, blue, yellow, we get this one, and if I click, it hides the message and shows me the wires again with new orders, so I can basically replay it. There you go. So next thing we're going to do is add some sounds to it. There's still one bug that we have here, but once we put in the sounds, that bug will kind of jump up and be very obvious, so I think it's better if we hear it. I was gonna say see it, but in this case, if we hear the bug, and then we can fix it after. Okay, so the sounds we have are under assets, we have our sounds, and we have a connect sound, which you can actually click and preview here. Error sound, select sound, and success. Let's start with success because that's one that we already know where it goes. So here in our game logic, we can go over here and let's say public, and this is going to be called an audio clip. And we can call it success sound. And to trigger sounds, there's different ways, but the way I'm going to show you is it's pretty practical. You just have to like remember what it's called. So over here, when we say that the end message happened, we can actually call a thing called audio source dot play clip at point. What play clip at point means that it's gonna play it at a certain point in 3D. We're gonna use that point in 3D to be our camera, so basically it's kind of gonna play next to our ears. So over here we can do success sound, and the position is gonna be camera dot main, which is our main camera, dot transform dot position. Now I know this looks complicated, but really all it's doing is saying, hey, play this clip in this position over here. And this particular position is a position of our camera. There are other ways to play sound that give you more control than this, but this is pretty practical, so I think this is a really good one to start with. So we go to our game logic, and again we see success sound is empty, so we can just drag our sound in there, and now we have that hooked up. Let's try it. Red, blue, yellow, and now the moment of truth. sorry if that exploded your ears. So that is the bug that I was saying earlier that we still have. So why does it sound like that? That was crazy, right? The reason for that is that the update cycle is checking if the wires are connected. And when they're connected, it just shows the message and that's it. But they stay connected. So basically every frame, it will come back and do the exact same thing. So it will call set active true over and over and over again. And it will also play the clip over and over and over again. So we gotta make sure that this only happens once. And there's a very easy way to do that. We over here can declare a new bool, just like we've done before. Bool, and we can say victorious. Did I spell it right? I don't know. Declare to false, and then over here we can say victorious equals true, because we just won by connected everything. And then in here we can say and not victorious. So that means if the connected wires are equal to all the wires and we're not victorious yet, then do this. But then when you go and do it, you're changing this to be victorious, so it will no longer go in here. Now, what does that mean? It means that this check will only work one time unless we reset this victorious. How do we reset it? Very easy. We go here into our reset wires and we can just call victorious equals false, because we know we're resetting everything. So let's try that again, and hopefully this time I won't destroy your ears in the process. Wink, wink. Excellent. Now I just play the once, and when we click, the wires reset. Let's make sure it works a second time. Wink, wink. Perfect. So now we have these three other sounds that go in the wire. So just like we did before, we do public audio clip, and we can call select sound. Then we can call the other two connect sound and error sound. And so we don't have to write this every time. We can literally just copy this line, go back here. So here's where we're actually connecting the wires. So we can just paste this here, and then we're here called connect sound. Where do we want the error sound? Well, probably here where it's when we're doing the mouse up. If we didn't connect, then we're resetting the position. This seems like a good place to put error sound. And where do we want the select sound? Well, probably when we start dragging. So over here, we can put select sound. And then we have to go to each one of our wires, and you can see we have these three empty things. Now, it's kind of annoying that we're now gonna have to like put this sound here, but then if we go to the next wire, it's not gonna be hooked up. So we're gonna have to do it one by one. But we can do that trick that we did earlier, and we can do, click on this, Control, 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 and then we can just drag select to select sound, drag the error sound to the error sound, and finally the connect to the connect sound. And that way now all four of the wires have it. Now in here we can just click. As you can see, we heard that when we selected. Now when we connect, so that's it, the game's complete. I know it was a lot. At the beginning of your game dev journey, there's so many things to learn and understand that it can be really, really overwhelming. If you get stuck on anything, leave it down in the comments and I'll try my best to help you out. Also, I would recommend that your next step would be to, once you get it working like the tutorial, try and modify it a little bit. I find that that really will help you to really understand and start to develop your own way of like implementing things. So for example, you could add a fifth wire, maybe add a time limit, things like that. If you want to see more of my face, I stream on Mondays, Wednesdays, and Saturdays on twitch.tv/PabloMakes. Hope to see you there. And also, if you learned something in this tutorial, if you enjoyed it, leave it a like, leave it a subscribe, help me out with the algorithm gods. And until the next one, I'll see you. Adios.
Well, thanks for stopping by. Don't forget to like, subscribe, and hit the bell to be notified when new videos come out. Thanks. Thanks for watching.